Hello, welcome to Physics Lab number 1. Here is your cart. It is going to be accelerated by this weight that we're going to drop off the pulley here. It's going to be accelerated by the weight until the weight hits the floor. At that time, it's not really pulling anymore, not providing any force, so there's not going to be any more acceleration. Back to the cart. The cart is going to accelerate, and as it does so, it's going to pull this timer tape behind it. The clicker here, our actual timer, is going to be hammering 60 times per second on this carbon paper. If you've ever done a carbon copy, that's kind of what this stuff is. It's just, with pressure, it leaves a black mark on the paper behind the cart here. So we're going to drop the weight from the pulley there at the top of the table, and it's going to provide a force until the weight hits the floor. So right now we have to figure out how far it's going to go. So we put this yardstick here, starting at 0 on the ground, coming up to about almost not quite 90. So the point here is to realize that we can only look at 90 centimeters worth of our paper tape trail from the starting point here, because any points after 90 centimeters will be after the acceleration is over, and we don't want to include those in our data, in our graph. Something to think about when we look at the dots on the tape afterwards. We know that the closer together the dots are, the slower it's going, because this timer here is going to pound out 60 dots per second. That's not an exaggeration. It's actually going to sound like just a vibration. It's going to sound like a machine gun. And so the farther the distance between those dots, the faster the velocity of the cart. And so we can tell the velocity by the distance between the dots, the distance traveled per 1/60th of a second. But how can we tell acceleration? Acceleration is different than velocity. Acceleration is how fast velocity changes. And when we look at the tape, we're going to be able to tell the acceleration by how fast, or actually what distance on the tape it takes for the dots to go very close together, because at the start, when we start this thing, the tape isn't going to be moving, so the dots are going to be on top of each other. So it's going to, when we look at the tape, the dots are going to be very close, and then they're going to separate. And if it doesn't take very much distance on the tape for the dots to go from close together to separated, that means there's a high acceleration. If it takes a long distance over the tape for the dots to get close together, and then finally a long distance later they get separated, we know the acceleration was slower. Alright, so let's actually do this thing. This is your lab, and it's all going to happen in about 10 seconds. Right now, maybe you can see there's a 200-gram weight that's dangling over the pulley over there, just ready to accelerate our cart. I'm going to turn on the timer right before I let go of the cart. And after I let go of the cart, it's going to accelerate across the table, and I'm going to sprint across the table and try to catch it before it goes off the other side. So here it goes. Our cart made it in one piece. It pulled the ticker tape through the timer. The timer slammed out 60 dots per second, and we can see them here. Oh, hopefully you can see them here. This was the beginning. It started with 0 velocity, and all the dots were essentially in the same place. And as the cart increased its speed, its velocity increased. There's more distance between the dots. As the dot's distance is increasing, the acceleration is a non-zero value. And I got out the ruler here so that we can take the first 90 centimeters of our ticker tape that corresponds to the distance that the cart was moving while it was being accelerated by the falling weight. So I'm just going to cut it right here. And we can kind of take a look at this. I have marked off every 12th dot here. I did every 12 because 12 dots corresponds to 12/60ths of a second, which is 0.2 seconds. So it took the cart 0.2 seconds to travel between the start here and the first line, another 0.2 seconds to get here, and another 0.2 seconds to get up here, etc.